All right, so this is 3-2, and I'm going to actually break this into two notes. And so this first one is going to be just function notation. And so this is not new. We've done this before, but I'm going to review this a little bit here before we get to a graph. So when we have this f of x, this is the same as saying y equals. So here I have an equation of a line, y equals mx plus b. So I have this equation of a line. And because of this, hold on, my camera's going in and out. I could create a little table over here, and I can say for every x that I plug into this, I'm going to have a y output. I can do this input-output table. So I can take a value of x, I can take this value, let's just say x equals 0. So I would say f of 0. That means, remember this is f of x, that means x equals 0. And when I plug 0 into this equation, I would have 3 times 0 minus 5, so this whole thing would be negative 5. I can take and plug in negative 2, so f of negative 2. That means x equals negative 2. So when I plug negative 2 in, I would have 3 times negative 2 minus 5. So when I do the math, I have negative 6 minus 5, which is negative 11. So all this function notation means is that I can take all of these random values of x and I write it this way, f of 0, f of negative 2. This means that the x value is whatever's in the parentheses. And I plug that in for the x in my equation and I get an output. Okay? So what this is saying is evaluate the following if f of x equals this. So this is the function that I'm using. And the first one here I have is just a negative 3. So what this is saying is f of negative 3 means everywhere I have an x in my equation, I'm going to plug in negative 3. Hold on, I'm going to fix my camera real quick. Okay, y'all, I think I fixed it. My autofocus was wigging out, so I think it's fixed. All right, so what I have is let me step back. So I have this function, and this says everywhere I have an x, I'm going to plug in a negative 3. Now be careful, because this is something that we tested on clear back in Unit 1. What this is saying is I have this x squared minus 2 times x. And I would encourage you, whenever you see something that's x squared, go ahead and write it like this. So I take this negative 3 and I pop it in here, and I pop this negative 3 in here. So what I know is that my function f equals negative 3. Negative 3 squared is a positive 9. And then negative 2 times negative 3 is 6. So I have 9 plus 6, which is 15. Now, let me give you a cheat on this. This was a number. I ended up with a number. This is saying I'm going to plug in this function of 2x. I'm going to keep an x in my answer. When you see an x in your answer here, you're going to end up with an x in your final answer. So what I have here is f of 2x equals parentheses squared minus 2 parentheses. Now, everywhere I have parentheses, I'm going to plug in this 2x. So what we know is because this is all inside, I'm going to square it all, so I end up with 4x squared minus 4x. Now, I cannot combine like terms. They're not the same, so I'm done. That's it. So remember, if there's an x inside your function notation, you're plugging in an x, you're going to have an x in your final answer. So I would do that mental check every time you do this. I have a negative x here. That means I'm going to end up with an x in my final answer. So x squared minus 2 times x. I plug in negative x. I plug in negative x. Now, I want to review this one more time. When you do this, this x is being replaced by the parentheses. And this x is being replaced by the parentheses. So when I square a negative number, it becomes positive. Negative times negative is positive. And so this is going to be my final answer. X squared plus 2x. Now, I have this negative that's on the outside of my function here. So when the negative's on the outside, it's the same thing as saying this. X squared minus 2x. I take this whole function, f of x. Well, this is f of x. So I take this whole function of f of x and I make it negative. So I can distribute this negative in, and I have negative x squared plus 2x. Okay, now this last one is a little funky because I'm putting an operation inside here. So I'm going to start the same way. I have parentheses squared minus 2 times parentheses. All right, so it looks just like this, and now I'm going to plug in that whole function. Now, biggest mistake is some of you are going to say x squared plus 4, but that's not what we have. I have 2 of these. I have x plus 2 times x plus 2 minus, and I'm going to just go ahead and distribute this right now, 2x minus 4. So I have to FOIL this. This is an easy one. You probably don't even have to think about this. And now I'm going to combine like terms for everything. So I have an x squared. My x's are going to go to 2x. And my 4 minus 4 goes away. So that's my final answer. Okay, so now what we're going to do is we're going to look at this from a graph. And so we have already done domain and range, but I think this kind of helps to solidify domain and range. So let's just look at this. So if we want to find the domain of this function, I'm going to go to my leftmost point. So my leftmost point looks like it's here, but it's actually going to keep going. So because it keeps going, I'm going to start at negative infinity in the x direction. I can drop a vertical line everywhere, everywhere, everywhere until I get over here to 7. 7 is a closed-in point, so I'm going to end at 7. All right, I want to look at my range now. So if I look at my range, it looks like my bottom point happens right here, but it doesn't, because this is going to tell me that it's going to continue in the negative direction. So I'm going to start at negative infinity. I can draw horizontal lines. I'm always going to hit my graph until I get up here at 4. And when I hit 4, it's a closed-in circle, and so I'm done. Okay? So now let's go back over here and look at this. So this says f of 0. Now what this is saying is what is y when x equals 0. That's what this is saying. Now if you remember, this is f of x. So to me, this is a no-brainer. X is right here, 0 is right here. So what is the y value when x equals 0? So x equals 0 is my y-axis. So if I go here to x equals 0, I'm going to go down here. Here's where I hit the graph. I hit the graph when y equals negative 2. Okay? This one, what is y when x equals 3? So I'm going to go over here to 3. I'm going to go down until I hit my graph, which happens right here. It's going to be negative 4. Okay? So what is y when x equals 8? So I go over here to 8. I go up, and I never hit my graph. I go down, and I never hit my graph. So this is going to be no solution. Or you can say undefined. There is no answer because when x equals 8, it is outside of my domain. Remember we said here the domain ends at 7, so I can't have a value at 8. Okay? Now this one is a little bit different. This says f of x equals 0. This is the same thing as saying y equals 0, right? We know f of x and y are the same thing. So if I want to know what f of x equals 0, what this is saying is what is x when y equals 0. So if I go over here, and I'm going to just highlight this. This is my my y equals 0 line. Well, here's what we notice. We hit here, we hit here, and we hit here. So this time I have 3 answers. So when y equals 0, x equals negative 5, and negative 3, and positive 6. Okay? So when y equals 0, let me go through this one more time. When y equals 0, that's this, f of x equals 0. Now, we know it's not f of 0 because there's not a value right here. It happens at negative 5, negative 3, and positive 6. Okay? The other one is saying, what is x when y equals 4? Well, here's my y equals 4 line. And I have 1 point, and that 1 point happens right here. My x value is 7. Okay, let's flip it over. All right, so this is going to take a bunch of different things and all put it together, right? So this is how you're going to see it on a quiz or on a test. So use the graph of f of x, that's this guy right here, to answer these questions. The first one is it a function? Now, we haven't covered this right now, but I know you did this in Algebra 2. So if it's a function, this means one of two things. Either x can't repeat, so it would be something like, in my domain, I would have x equals -2, -1, 0, x doesn't repeat, or it has to pass the vertical line test. And this is when we drop vertical lines, and the vertical line test says that it only hits one part of your graph. So if I drop a vertical line anywhere along this graph, I'm only going to hit 1 point. So is this a function? Yes, because it passes VLT. Okay, x-intercept. X-intercept is where it hits the x-axis. So it hits the x-axis here, and here, and here. So I have 3 points that hit the x-axis. -2, 0, 4, 0, and 8, 0. Y-intercept, where does it hit the y-axis? It only hits the y-axis right here. So that point would be 0, -3. Okay, so now we go into function notation. Now, what I'm going to do right under this is I'm going to write it this way, f of x, and hopefully you see what you're doing is you want to know what is y when x equals 3. So I'm going to go over here to 3. I'm going to go down on my graph to find my y value. So when x equals 3, it's right here. Down on my graph, this is going to be -2. Okay, so this says f of x equals 3. So what happens when y equals 3? So when y equals 3, that's this point right here. And when y equals 3, I see I have two values. I have a value right here. So the x part of that, so it says what is x? X is going to be -3. If I go over to this point and I go down to my x-axis, this is going to be 6. Okay, last question here. What is f of 0? So again, f of x. So if I look at this, this is my f of x value. I go down here, it's -3. Now let's talk about this for a second. This, when x equals 0, this is the same as the y-intercept. And we see that up here, right? So when x equals 0, it's the y-intercept. So if we go over here, this is the same as y equals 0. This is the same as the x-intercept. So if I look at this, I already know here's my y equals 0 line. I'm going to have 3 answers, -2, 4, and 8. Okay, I'm going to go ahead and pause the video, and I want you to pause the video, and I want you to work number 4, and then we'll come back and check answers. Okay, so this one was a lot harder, so let's talk about this. Go ahead and check your answers. This is the last part of the video, so if your answers are right, then you can go ahead and stop this. Otherwise, make sure you listen to the explanations here. So when g of x, so when x equals 2. So if I go over here to 2, you can see I circled this. And if I want to find my x value, or sorry, my y value, I have 2 points. I have a point here and I have a point here. But remember, what we know about an open circle is it's not included. So I really don't have 2 points. I only have 1 point because this is included. It's a closed-in circle, so my value is going to be 3. Okay, this one's pretty self-explanatory. When x equals 0, I only hit 1 point at y. When this function equals 0, when y equals 0, I have 3 points. But let's talk about part D. So part D is saying when y equals -2. So I highlighted this line right here, when y equals -2. And what happens is we have an open circle. So because I have an open circle, I don't have an answer on this side. However, if I took my line and I extended it clear over here, what happens is I have this point right here, And this point, I'm going to get rid of this. This point is actually 7 because I'm going to hit x at 7. So I don't have a point here, but I do here at 7. So this is undefined at x equals -3. So this was a little misleading. Sorry about that. I didn't actually see this line until I was going through this with you. So when we have an open circle, we don't include it as one of our values. We see this here with x, and we see this here with y. Okay?